Okay, section 6.3, we've talked about random variables and taking the sum and difference and finding the mean and standard deviation. Now we're just focusing on a binomial random variable. So the first thing we have to do is make sure that it follows, that we have a binomial setting, otherwise none of this applies. So if we have a binomial setting, and the way to check that, a little mnemonic to remember, is bins. If all four of these conditions are met, and we're going to practice that in just a second, then we can say it's a binomial setting. So B stands for binary, and that means that either you have a success or failure. So say you're shooting a basket and you either make it or you don't. So that's one of the conditions. Success or failure, binary. Independent. So each trial, the probability of one does not affect the other. That means we have met the independence condition, so that's the probability of one event does not affect the probability of the next happening. N stands for there's a fixed number of times we're going to do something. So we're going to try to shoot a basket and make it 10 times. So number N is for number of trials. It's fixed ahead of time. We use N for that, and that is fixed ahead of time before we start. And then S is for the probability of success. So the probability of success has to stay the same for each trial. So if you're shooting baskets, for example, the probability of making it shouldn't be different in between each shot. So that would be, we use the variable P, which we'll use in the formula in a second. The probability of success is the same each time for each trial. So that's P, probability of success. So then, if we've met all four of these conditions, they all have to be true, then to figure out the probability that some event would occur, we can use the binomial probability formula, which is actually, it looks harder to use than it is, and once you see an example, you'll see the pattern, and it will be very simple. So binomial probability formula is this: if you have a random variable x that has a binomial distribution, so you have to check bins first, and you have n trials, probability of success on each trial is P, probability of success P, then it is this: the probability that you would have success on a certain number of trials. Let's say you shoot the basket 10 times and you want to know if you're going to make 3 of them. So the probability x equals a constant, like 3, is equal to, and then you would use combinations, n choose k, times the probability of success raised to the k power, because you want to have success k times the complement, 1 minus the probability raised to the n minus k power. That's the number of failures. So you use combinations to figure out the number of ways the outcomes can happen. This is probability of success, probability of failure. Let me just make a note here that k stands for the number of successes. And here you can use your calculator, and you can just go math PRB, and then you'll see the little n choose R. If you're using your graphing calculator, that's just where it is, where you can do combinations. And the last thing I want to add to this before we actually use this in an example is that you can get your calculator to do this formula for you, and you would still get full credit as long as you label each parameter. If you do binom PDF for a binomial distribution, and you enter n, the number of trials, P, the probability of success, k the number of times you want success to happen. That will give you the probability that x equals k. Or if you want to do cumulative with less than equal to, you can use binom CDF. These parameters are the same, NPK, and that will give you the probability that x is less than equal to k. And where this is on your calculator, it's in the book, it's referred to on page 389, but you would go to second vars, same place where you did normal CDF, because for normal CDF, that's for a normal distribution. This is a binomial distribution. And later on, we're going to get to when you can approximate a normal distribution with a binomial. We'll get there. But if you go to second vars and scroll down, you'll see these two, those two